block elements. In the class 11th, we have already learned the P block elements, and we also know that they are placed in the groups 13 to 18. They are placed in the groups 13 to 18 of the periodic table. Their valence shell electronic configuration is NS2 NP1 to 6. These are all are basic that we have learnt in the 11th class. The properties of p block elements, like that of others, are greatly influenced by atomic sizes, ionization enthalpy, electron gain enthalpy, electronegativity. These are some of the properties of the p block elements. These are some properties p block. Let us understand what is p block elements. Here we have already learnt the groups 13 and 14th of the p block elements in the class 11. 13th and 14th group elements we have learnt already in the class 11. So we will learn about group 15 elements. What are p block elements? The elements in which last electron enters the valence p subshell are called as p block elements. P block elements are the elements in which the last electron will enter the valence p subshell are called as p block elements. Okay. They include elements of the group 13 to 18. P block elements mainly consist of the 13 to 18. They include metals, non-metals and metalloids. P block elements mainly consist of metals, non-metals and metalloids. Group 13 and 14 already discussed in the class 11th. So we are going to discuss the group 15 elements. Group 15 mainly includes nitrogen, phosphorus, arsenic, antimony and bismuth. Group 15 mainly consists of 5 elements. They are nitrogen, phosphorus, arsenic, antimony and bismuth. General electronic configuration of p block element. The outermost electronic configuration of p block element is ns2np ns2np 1 to 6. 8th group elements: nitrogen, phosphorus, arsenic, antimony and bismuth. You can remember these 5 elements easily by NAPAP, as you say all the time, Binod. Similarly, you say napap, napap, napap all the time. Here N determines nitrogen, P determines phosphorus, A determines arsenic and A also determines antimony, B determines bismuth. Here the symbols are different. Nitrogen N, phosphorus P, arsenic AS, antimony SB, bismuth BI. Elements. These 15th group elements are also called as nitrogen family. 15th group includes nitrogen, phosphorus, arsenic, antimony and bismuth. As we go down the group, the metallic character increases. Obviously, and it consists of 5 elements. They can be remembered by the word napap. Occurrence. 78% by volume of the atmosphere contains molecular nitrogen. 78% in the atmosphere we have nitrogen. From Earth's crust it occurs as sodium nitrate NaNO3, which is also called as Chile saltpeter, and potassium nitrate, which is also called as Indian saltpeter. Okay, NaNO3 it can be found. Nitrogen can be found in 78% of the atmosphere, and it also found in earth crust as a sodium nitrate and potassium nitrate. We can get the nitrogen. Next comes phosphorus. Phosphorus occurs in minerals of the apatite family. Phosphorus mainly comes as the minerals. The mineral family is called as apatite family. Also present in bones, rock, egg, milk and bones. Okay, for bones, rock, egg and milk it is mainly present. It also occurs as minerals in the apatite family. Arsenic, antimony and bismuth are found mainly as a sulfide minerals. They are found as a sulfide minerals. Phosphorus are found as a minerals of apatite family, whereas nitrogen can be found as in the atmosphere, 78% of the atmosphere, and also from the earth crust. It occurs as the sodium nitrate and potassium nitrate. Arsenic, antimony, bismuth, these three elements are mainly found as sulfide minerals. For example, stibnite and bismuth glands. Trends of the some atomic, physical and chemical properties of the group which are discussed here: electronic configuration, atomic and ionic radii, ionization enthalpy, electronegativity and physical property. The first one is electronic configuration. The valence shell of electronic configuration is ns2 np3. The electronic configuration of nitrogen family is ns2 np3. Here the p orbitals are half filled, making their electronic configuration extra stable. Here what happens, here the s orbital, this s orbital is completely filled. So s orbital is completely filled, but p orbital, this p orbital is half filled. This p orbital is half filled, so it makes this electronic configuration more stable, more stable. Next one is atomic and ionic radii. Down the group, covalent and ionic radii increases. As you go down the group, see here, as you go down the group, what happens? Atomic and ionic radii increases. How it increases? See, and ionic radii increases. It basically increases because there is a considerable increase of covalent radius from N to P, means nitrogen to phosphorus. There will be increase in the covalent radius. However, from arsenic to bismuth, what happens? Arsenic to bismuth, what happens? Only there will be small increase in the covalent radius is observed. This is mainly due to the presence of completely filled d and f orbitals in the heavier membranes. Why there is increase in the covalent radius from N to P? Because there is due to the presence of completely filled d or f orbitals in the heavier members. Next, ionization enthalpy. Down the group, ionization enthalpy decreases. As you go down the group, ionization enthalpy decreases. Due to extra stability of half-filled p orbitals and smaller size, these elements ionization enthalpy is much greater than 14th group elements. What happens here? The decreases down the group due to the gradual increase in the atomic size. As the atomic size increases, so there will be a decrease down the group. Because of the extra stable half-filled p orbitals, electronic configuration and also the smaller size, the ionization enthalpy of the 15th group elements is much greater than that of a 14th group elements in the corresponding periods. Next one is electronegativity. As we go down the group, electronegativity decreases. Why the electronegativity decreases down the group? As you go down the group, electronegativity increases with the increase in the atomic size. Atomic size also increases. What increases? Atomic size also increases. However, amongst the heavier elements, the difference is not that much pronounced. Okay. There are some physical properties. Nitrogen and phosphorus are non-metals. Arsenic and antimony are metalloids. And bismuth is a typical metal. Here, nitrogen and phosphorus are non-metals. Arsenic and antimony is metalloids. Bismuth is a typical method in the nitrogen family. Down the group, boiling point increases. Except nitrogen, all elements show allotropy. As you go down the group, boiling point mainly increases. But nitrogen, except nitrogen, all elements show allotropy. Here, what is allotropy? Allotropy refers physical form. The trends which I have written in the short way: electronic configuration is ns2 np3. It is half filled because s is half filled, and sorry, S is fully filled, P is half filled, so it is extra stable. Atomic and ionic radii increases as you go down the group. Atomic and ionic radii, what happens? Increases. Next comes ionization enthalpy. As you go down the group, ionization enthalpy decreases because of the extra stability of the half filled p orbitals and also due to the smaller size. This happens. Next comes electronegativity. Electronegativity, as you go down the group, electronegativity decreases. Next comes the physical properties. Physical properties, as I have told you, nitrogen and phosphorus, what are they? They are non-metals. They are non-metals, whereas arsenic and antimony are metalloids. Bismuth is a typical metal. What happens of the boiling point? Here, as you go down the group, boiling point increases. Boiling point increases. Here every element show allotropy, but the nitrogen do not show.